Now D6 high speed HS. For D6 high speed means total number of electron is 6. This is a 5 electron. Now 6 electron. 6 electron, where it will go to the 6 electron? So this is all these rooms 1, 2, 3, 4, 5. 5 rooms are there. So all these 5 rooms is occupied by 1 electron. So where the 6 electron will go? 6 electron will go to the lower energy level, because it has no other option. So it has no other option. So it will go to the lower energy level. So it will come to this lower energy level 6. So in case of D6, the crystal field separation energy, it will be T2G level, the number of electrons is 4. So 4 into minus 0.4 delta O plus in EG level only 2 electron. So 2 into plus 0.6 delta O. Total will be minus 1.6 delta O plus 1.2 delta O. So means minus 0.4 delta O. Now here there is one pairing. So one pairing means you have to write here plus 1p. Right? Now number of unpaired electron n. Here number of unpaired electron will be 1, 2, 3, 4. 4 only unpaired electron. N equals to 4. So mu value will be root over 4 into 4 plus 2 both magnetic. Okay. Now in case of low spin complex means this 4th electron, 6th electron. So already 5th electrons are there. So 6th electron will again come here. Okay. 6th electron again come here. So in case of T2G level, because EG level, T2G level still one place is vacant, means not vacant. In there are 3 rooms. All rooms there are 2 electrons occupied. One room was there where there is only 1 electron. So 6th electron will come here. Okay. So for D6 low spin, so total number of electrons in T2G level, there is now 6 electrons. 1, 2, 3, 4, 5, 6 electrons. So 6 electrons in T2G level, their energy is minus 0.4 delta O plus EG level no energy. EG level is vacant, no energy. So no energy means 0. So overall energy will be minus 0.4 into 6 means minus 2.4 delta O plus pairing energy. There is 1 pairing, 2 pairing, 3 pairing. So 3 pairing means there will be plus 3p. Okay. And magnetic moment, N value, there is no unpaired electron. All electrons are paired. So magnetic moment it will be 0. N equal to 0 means magnetic moment will be 0. Okay. So for D6 system, high spin, the CFSE value is minus 0.4 delta O plus pairing energy, and D6 low spin minus 2.4 delta O plus 3p. Okay. Now if you compare D4 system, D5 and D6 system, you will see always the CFSE value is higher in case of low spin complex. Right? There is minus 0.6. There is minus 1.6. Negative indicates the stability. Negative energy means indicating the stability. Positive indicates the positive means less stable, negative means more stable. So if we compare for D4, low spin complex is more stable because it is minus 1.6, which is only minus 0.6. D5, no CFSE value is 0, but here CFSE value is minus 2.0. So this one is most stable, low spin complex. D6 also you can see there is minus 0.4 only, and this is minus 2.4. So D6 also low spin complex most stable. Means whenever we are making complex with strong field ligand, the splitting is high and complex becoming much more stable. Because of that, it is called stabilization energy. Okay, crystal field stabilization energy. The amount of energy is generated because of crystal field theory. Means because of this crystal field. Here, crystal field means there is an octahedral field. So because of this octahedral field, this amount of stabilization energy, energy that is stabilizing the complex. Okay. So always remember that low spin complex will be more stable. More stable means they will be less reactive. Now if we compare the reactivity of two complexes, for example, one is, let's say, cobalt 3 plus. Cobalt 3 plus means D6. Right? Cobalt 2 plus D7, cobalt 3 plus D6. Now if we take two complexes, cobalt CO F6 3 minus and if cobalt Cn whole 6 3 minus, if we take these two complexes, then cobalt Cn whole 6 3 minus, this is our low spin complex, low spin, and this will be our high spin complex, HS. So low spin complex will be more stable complex, means it will be less reactive, and this will be more reactive. So we can also compare the reactivity of complex based on this CFSE calculation. Okay. Now last one we have to calculate the D7. Okay. Next one, D7. Now in case of D7 system, so this is our D7. So D7 for high spin complex, seventh electron, it will come here, low energy level, right? So for D7, high spin T2G, EG, for D7, so high spin complex, in T2G level energy, total number of electrons is 1, 2, 3, 4, 5 electrons. So 5 into minus 0.4 delta O plus EG level there is 2 electrons. So 2 into plus 0.6 delta O, because EG level energy is plus 0.6. So total energy will be minus 2.0 plus 1.2 is the minus 0.8 delta O plus there is 2 pairing. So we have to write here plus 2p. Okay. And magnetic moment also you can calculate. Mu value here, mu will be 1, 2, 3 ampere electrons. So mu equals n equal to 3. N equal to 3. So mu will be root over n, 3 into n plus 2. Okay. Now if we take D7 low spin means in D6 this part is already filled up. Right? Now D7, 7th electron, it has to come in the EG level because there is no other option. T2G level is already filled, means one room can be occupied by 1 electron, maximum 2 electrons. Third electron cannot come here. So third electron, there is no space in the T2G level for the third electron. So third electron will come to the EG level. So for D6, D7 LS, low spin, T2G level total number of electron is 6 into minus 0.4 delta O plus EG level 1 electron, 1 into plus 0.6 delta O. So total energy will be minus 2.4 delta O plus minus 2.4 delta O plus this will be plus 0.6 delta O. Total will be minus 1.8 delta O plus 3P. 3P we have to write here because there is 3 pairing, 1, 2, 3 pairing. And magnetic moment we will get only for these unpaired electrons. So N equal to 1. So mu will be root over N into N plus root over N into N plus 2. 1 plus 2. Okay. So for D7 we are getting value is whatever the value we are getting, that is high spin complex, it is minus 0.8 delta O plus 2p, 2 pairing, and for low spin complex we are getting minus 1.8 delta O plus 3 pairing, right? So again you can see for D7 also delta value is higher, CFSE value is much lower in case of low spin complex, minus 1.8 delta, and this is minus 0.8 delta 1. Okay. So up to D7 I discussed. Now D8 system. In D8 system we will get some interesting thing. Now D8. D8 means this is the 8th electron. Now in case of high spin complex, so this 8th electron, okay, it will come here, lower level T2G level, right? And in case of low spin complex, this 8th electron has to go here, right? In case of D8 system, the 8th electron it has to come for T2G. For high spin complex, it will come here in the T2G level, and for low spin complex, it has to go here, right? Now for D8 system, if we check the electronic distribution in high spin and low spin, you can see it is same, right? For D8, if we check for D8, for high spin and low spin, we will get same electron distribution. T2G level 6 electron, EG level 2 electron. T2G level 6 electron, EG level 2 electron, right? So therefore, the CFSE value differ for high spin and low spin complex only for D4, D5, D6 and D7 only. D1, D2, D3 and D8, D9 and D10 will get same CFSE value for high spin and low spin complex. For D8 if we calculate CFSE value, we don't need to write here HS or LS because for D8 we will get same CFSE value and same magnetic moment for high spin and low spin, both cases same. Right? So for D8 I am not writing here HS or LS. So D8 it will be total number of electron in T2G level is 6. So 6 into minus 0.4 delta O plus EG level there is 2 electron, 2 into plus 0.6 delta O. Okay. And here total number of pairing is only 3 pairing. So we can write here plus 3p. Okay. So total will be minus 2.4 delta O plus 1.2 delta O plus 3p. Means total will be minus 1.2 delta O plus 3. Okay. So for D8 system, CFSE value for high spin and low spin, both cases we will get this minus 1.2 delta O plus 3p. And magnetic moment N number of unpaired electron, both cases same. They are in high spin, number of unpaired electron will be 2. And for low spin also, number of unpaired electrons will be 2. So this high spin and low spin, this concept is no longer valid, right, for D8 system. We are talking about high spin and low spin based on the number of spin. When the D8 system is coming, both cases same number of spin, N value is 2. So this high spin, low spin, these things is not valid. But delta value, okay, so we will get same CFSE value and magnetic moment value will be also same. Mu value will be also same, right? Root over 2 into 2 plus 2, right? But the splitting will be different, right? Splitting is different. So splitting is different means if we take the spectra will be different. For example, if we take two complex nickel fluoride NiF6 4 minus and NiCN whole 6 4 minus this complex is the strong field ligand and there is the weak field ligand. So in both complex the CFSE value will be same, magnetic moment is same, but the absorption spectra will be different. If we write a wave number, nu bar, wave number, so absorption spectra, it will be for nickel cyanide complex CN whole 6 4 minus, it will be nickel chloride complex. Right? Why different? Because for cyanide the delta value is high. We already discussed that delta value depends on, there are maybe many factors, ligand factor is there, factor number 2. If there is strong field ligand, delta value will be high. So delta value is high. So when the electron transition occurs from lower to higher, the energy gap is very high. Means the energy gap is very high, energy is equal to h nu, or you can convert this frequency to wave number. So frequency is high means wave number will be also high. So we will get the band in higher wave number. For fluoride complex, the energy gap will be low. We will get band in the lower energy level. Okay. So this is the way we can calculate the CFSE value for high spin, low spin complex, and it is only valid for D4, D5, D6, D7, D1, D2, D3, D8 and D9. We will get same CFSE value, but spectral band will be different. Okay. So this is all about the crystal field theory. Last 3 lectures I given. In this 3 lecture I discussed d orbital splitting, spectrochemical series, then what are the factors on which this splitting energy depends. Then I discussed the crystal field solution energy calculation in case of tetrahedral field and octahedral fields. Thank you everyone for listening.